Hello, scholars. Me again. Wanted to take you through the example for this week's work. We're going to be adding and subtracting vectors in application problems. And there are 4 steps. If you look on the worksheet, there are basically 4 steps to doing this. The first step we'll call A is drawing your vectors and expressing them in magnitude and direction format. Now, that may mean that we have to take it from magnitude format with bearings or magnitude format with map bearings, but we have to change it into regular direction format. So we'll do that. Secondly, you want to take the magnitude and direction format, convert that into components. And there are 2 steps to doing that, and we'll do that. The third step is probably the easiest. That's when you add your components. And then the 4th step, once you have your components added, is you're going to reconvert your components back to magnitude and direction form. So let's go ahead and look at the example. The example says, and that's the wrong page, the example says an airplane has an airspeed of 500 kilometers per hour and a bearing of 40 degrees north of west. So that's a map bearing. It's 40 degrees north of west. So let's draw that. If we go to draw, let's draw it in black. On our coordinate plane, this of course is north, south, east, and west. So it says 40 degrees north of west. So north of west is over here. And this angle is 40 degrees, right? And it has an airspeed or a magnitude of 500. So this is 500. Now, that unfortunately is not in regular direction format. So we have to figure out the direction angle. And the direction angle is the angle that starts at 0 and goes all the way around. So if this is 180, and this is 40, 180 minus 40 makes that 140 degrees. So the first one is 500 at 140 degrees. Okay? The second vector, it says the wind velocity is at 60 kilometers per hour in a direction south of west, 38 degrees south of west. So let's draw that. This again is north, south, east, and west. South of west would be over here, and this angle would be 38 degrees. 38 degrees south of west, and it is 60 kilometers per hour. Again, if this is 180, this would be 180 plus 38 is going to be 218 degrees. So this one is 60 kilometers per hour at 218 degrees. Again, draw your vectors. Since this is north of west, we came up with 500 degrees at 140, 500 at 140 degrees, and 60 at 218 degrees. That is your first step. So that gets us ready for step 2. And step 2 is to convert the magnitude and direction into component form. So we already have our magnitude and direction, our magnitude, when we're going to component form. And it's 2 very simple steps for that. First, we take the magnitude, 500, and we multiply it by the cosine of the angle because cosine refers to the x, and then the magnitude times the sine of the angle. Once we do that, that will give us the components for the first vector. The second vector will be 60 cosine 218 and 60 sine of 218. And those will give us those calculations. Now let's see what those are. I've already plugged that into the calculator. So that's here. 500 cosine of 140 is negative 383. And 500 sine of 140 is 321.4. So let's go back here and go negative 383.0 and 321.4. And then that's negative 47.3 and negative 36.9. So that's negative 37.3, negative 36.9, right? Let's look at that again and make sure. And that's 47.3. And those are our components for the vectors. So that is step 2. We take the vectors in magnitude and direction form, and we change them by multiplying them by the magnitude and the sine and the cosine of the angle into components. And that is step 2. So now we're ready for step 3. And step 3 is when we take the components. Let's take the draw off. It's when we take the components that we have now and we can add the components. Well, that's pretty simple because we just add the x to the x and the y to the y. So that would be, I like purple now, that would be negative 383.0 plus negative 47.3 and 321.4 plus negative 36.9. And that would be, if we add that, negative 383.0, I think I can go to the calculator and do that. Negative 383 plus, let's move my face over here, 0.0 plus negative 47. So let's backspace. Negative 47.3. Boy, I messed that up. Negative 383.0 plus negative 47.3. And that gives us negative 430.3. And then we have 321.4. And we're adding to that negative 36.9. And that gives us 284.5. So negative 430.3 and 284.5. Our result is negative 430.3 and 284.5. So this is our answer, but it's our answer in component form. And since the problem asks for magnitude and direction, we're now ready for step 4. And step 4 is when we change these components back to magnitude and direction. So let's go ahead and move up and do step 4. We have negative 430.3 and 284.5, and we have to change it back to magnitude and direction. So to get the magnitude, I must hit draw first. Okay, purple is fine. To get the magnitude, I have to take the square root of 430.3 squared plus 284.5 squared. So let's go to the calculator. The square root of 430.3 squared plus 284.5 squared is 515.8. So the magnitude is 515.8. And to get the direction, of course, come over here, we're going to do the tangent inverse and this is for the direction. The tangent inverse of 284.5, that's the y, over 430.3, that's the x. So let's go to the calculator. Tangent inverse of 284.5 over 430.3, and that gives us 81.39 degrees. Did I type that in right? Nope, I did not, because that says 2,845. So let's go 284.5 divided by, let's go here. Let's mess that up big time. So backspace. And can I just go in there and put a point? Yes. All right, so that's 33.5 degrees, 33.47 degrees. Okay, after all of that. So that's 33.47 or 33.5 degrees. Now, this is in the second quadrant. So, in the second quadrant, this angle is 33.5 degrees. So it's going to be 180 minus that. So we have to do 180 minus 33.5 degrees, and that's going to give us 146.5 degrees. So at 146.5 degrees. And that is our vector in magnitude and direction form. So again, the 4 steps are to draw your vectors and place them in magnitude and direction format. They may be given to you in magnitude and direction format, but just in case. Convert the magnitude and direction into components. Add your components, and then take your components and change them back into magnitude and direction. Those are your 4 steps. I invite you, as you are doing the work, to rewind the video and allow the video to take you through each step, and that will make the work that much easier. Okay, if you have any questions, you're welcome to email me or text me, I guess it would be, or message me on Teams, but this is going to be the example for your assignment this week. Have a great day. Bye.